Okay, so this video is going to be for Chapter 4B, review number 14B, and 15, which is related to 14B. And this one is graphing a piecewise function and then answering some questions about a piecewise function. So we've got g of x here, and it's divvied up into three chunks. And so I'm going to divvy my graph up into three chunks. So one of the chunks, this part right here, tells me what my chunks are. So one of the chunks is going to be for all the x values that are less than -5. So let me mark that on my picture here. So let me actually do this. -1, -2, -3, -4, -5. I'll go a couple more, -6, -7. So here's -5 though. And right there, I'm going to divvy this up right here. So everything less than -5, I want my graph to look like y equals 1. Right? So over on this side of the graph, I want y to equal 1. And I want it to equal 1 up to, but not including when x is -5. So just for my own notation, I'm going to put a little parentheses here to show go right up to -5, but don't include it. Okay. The next chunk is going to happen between -5 and -2. So I'm going to draw a line at -2 here. -2 all the way down. Okay. And this region of the graph, when I'm between -5 and -2, I want my graph to look like y equals 2x plus 3. So this region right here should look like y equals 2x plus 3. And I want it to look like that all the way down to and including when x is -5. So I'm going to put a little bar there so I remember include that the dotted line for that part. And then -2 I'm not including, so I'm going to go up to the dotted line but not quite on the dotted line. And then the next part here, the last part, notice I skipped some x's here. So the region in the middle, like this region right here between -2 and 0, there's not going to be anything to graph there. So at least that saves a little time. So my other part is everything bigger than 0. So I'm just going to draw a dotted line next to 0 there. And on this side of the picture, everything from 0 and up, I want this graph to look like y equals -x squared plus 6. Okay, so that's what I've got. So now it's just a matter of, well, let's graph each chunk. Okay, so for y equals 1 normally looks like, you just go up 1 and you draw a line right through, a horizontal line right through there. But I don't want the whole graph. I just want the part when x is less than -5. So here's -5. I just want this part over here. So let's graph that. Here's 1. And so my line will look like this, going that way. There's y equals 1, right? But I only want it up to, but not including the dotted line. So to make sure that that shows up properly, I'm going to put a big open dot right at -5, right on that line. And then let's label that point just so you have it. So this point right here is -5, 1. And I'm going to mention that it's an open dot, just so we don't forget. Okay. To graph a line, you really are supposed to have a couple points. So you pick any other point on there, like this one would be -7, 1, if you wanted to be, careful about it. Okay, so the middle chunk is, this region right here in the middle is supposed to look like 2x plus 3. And the mistake that students sometimes make is they say, well, I'll start at 3 then. And I'll go up 2 and over 1, and up 2 and over 1, and here's my line. But that's in the wrong region. That's not the zone that I want to graph this thing in. I want to graph it in this middle zone right here. So if I make a little mini chart for it, let me get rid of this. So if I make a little chart for it, x's and y's, well, I'm plugging into y equals 2x plus 3. And the smallest x I can use here in my region is -5. So let's go ahead and plug that one in. So if I plug in -5, I've got 2 times -5 plus 3, which is going to be -7. So I know the point -5, -7, -1, 2, 3, 4, 5, 6, 7 is going to be on my picture. And I want to include that point because I'm actually allowed to use x equals -5. So right here, since I'm including that point, I'm going to use a solid dot, a closed dot. So this point right here, -5, -7. Okay? I got to go all the way up to x equals 2. So if I were to plug in x equals, or sorry, -2, if I plug in -2, then I've got 2 times -2 plus 3. That ends up being -1. But notice, I don't want to actually make that a closed dot. I want that one to be an open dot because I go up to -2 without ever quite getting there. So that one, I'm going to put an open dot. So I'll even note that. Open dot here, closed dot here. Oops, sorry. Closed. So here's the other one right here, open dot. And it's a line, so I don't need any other points along the way. I can just connect them right here. So there's that part of the graph. Okay, so remember the middle chunk is just empty, so I'm just going to skip this region right here, right? Nothing goes there. The last part is y equals -x² plus 6 for everything 0 and bigger for the x's. So that's going to look like a parabola. So let's kind of think about the parabola a little bit. The vertex is going to be the x-coordinate of the vertex is going to be -b over 2a, which is going to be -0 over 2 times -1, which is just 0. Then if I plug that back in, I'm going to get 6. So my vertex is at 0, 6, and I am allowed to plug in 0. So if I plug in 0, let's see, 4, 5, 6, I've got that point on my graph right there. So this point right here is 0, 6, which happens to be the vertex, and I do include it, which I noticed before with that bracket. So let's pick a couple more points on the parabola. So if I make a little chart for that one, x, y, this one we're plugging into y equals -x² plus 6. The smallest one I could have plugged in was 0. And then we'll just pick a couple more points, so 1 and 2. So if I plug in 1, I've got -1², which is 1, so -1 plus 6 is 5. If I plugged in 2, this would be a 4, so 6 plus -4 would be 2. So then I've got a couple more points. I've got 1, 5 right there, and I've got 2, 2 right here. And then if I graph that part, it looks like a parabola kind of doing one of these deals. And so there's my picture. So if you wanted to clean it up a little bit, the final picture should look just like this. Basically all the purple parts are gone. I'm not going to erase those because then I'm just going to erase a bunch of stuff in the way. But really your final graph, the whole thing, just looks essentially like that. Which is a ridiculous looking graph, but that is the correct graph. Okay, so let's look at 15, which is finding the following values using that same function. And so what I did, since it won't all appear on the same screen, I just recopied the function right here. So there it is. So let's look at g of -1. That means that x is -1, and we want to know what the y value is. So if x is -1, well, this thing right here tells me what to do with it, right? Well, if x is less than -2 and bigger than -5, then I can plug it into the middle function right here. If x is bigger than 0, I can plug it into the other, this equation right there. But the problem is there's nothing for x equals -1. So it turns out if x is -1, g of -1 just doesn't exist. Does not exist. And if you actually checked it with your picture, it's saying when x is -1, what's y? Well, when x is -1, there is no y value for it. So that's why it doesn't exist. Okay, that's probably not the best one to start with. That's kind of a trick question right off the bat. So let's look at this one. What if x is 1? Well, so if x is 1, then the g I'm supposed to plug it into, 1 is bigger than 0. So that fits this, which means I gotta use this part of my equation. So if x is 1, then g of 1, I'm plugging it into the bottom equation, is -1² plus 6, which is gonna be 5. And if you went up and double checked, well, when I plugged in 1, I got 5 on my graph. So that's right, 5. Okay, let's keep going with this. If x is 2, well, my blueprint down here, 2 is bigger than 0, so I'm going to use this equation. So then that means g of 2 is going to be negative 2 squared plus 6, which is going to be 2. Let's take a look at negative 5. So if x is negative 5, g of negative 5 should be, well, negative 5. If it's less than negative 5, if x is less than negative 5, then g of x is just always 1. But I'm not less than negative 5, I'm equal to negative 5. So that means I got to use this one, because that's where the equals negative 5 comes in. So I plug in negative 5 into this part right here. So g of negative 5 is 2 times negative 5 plus 3, which is going to be negative 7. And if you come back up to your picture, when x is negative 5, I kind of have 2 points. I have this one and this one, but the only one that counts is the filled in one. So that's why I choose the negative 7 over the 1. Okay. G of 0. Let's see, g of 0. So that means x is 0. And g of 0 is what's the y value. And so if we come back down here, well, x is 0, so I'm using the third equation again, the third part of the equation. So that's going to be negative 0 all squared plus 6, which is going to be 6. And then we've got x is negative 100. So that means g of negative 100. If I'm using negative 100, that fits this part right here. Well, g of anything that's less than negative 5 is going to be 1 every time. So it's just 1. And if you kind of look at your picture, well, any x value I plug in that's way down here is going to give me a y value of 1 every time, so that's why that works. Okay, so I hope that helps a little bit. I realize that this stuff can be a little confusing, but keep at it and it will get easier. So, okay,